Howdy folks, Mr. K here with an online video discussing what solutions are. Now, we've already somewhat discussed solutions when we discussed mixtures. So we're going to be going a little bit more in depth this time because we use a lot of solutions in a chemistry lab. Most of what you deal with when it's a liquid is a solution. Solutions are, keyword, homogeneous mixtures. Remember, prefix homo means they all look the same. It looks constant throughout. And they're mixtures, meaning that they're physically combined. You can separate a solution, just like a mixture, by letting the water boil off. Some examples of solutions are ocean water, which is a solution of salt in water. Syrup, which is a solution of sugar in water. Or copper chloride solution, which is a solution of copper chloride in water. Things to notice that's common. They all are see-through or transparent. Because remember, they're homogeneous, meaning they're uniform throughout, so they're typically, you can see through a solution. They all have two parts. Solutions always have two parts to them, and one of the parts is very commonly water. Usually, most times when you have a solution, one of the parts is water. Now let's talk about the two different parts. The first part of the solution is what's referred to as the solute. That is what is being dissolved. The other part is the solvent. That is what's doing the dissolving. So if I'm making Kool-Aid, the Kool-Aid powder that goes into it, that's the solute. The water, which I have more of, is the solvent. If I'm making chocolate milk, the milk would be the solvent. The chocolate would be the solute. If I'm making lemonade, the lemon juice and sugar, that's going in. That's what's being dissolved in lemonade. That's the solute. Water is dissolving it. That's the solvent. Solutions have two parts, the solute, which is being dissolved, and the solvent, which is doing the dissolving. There's ways that we affect the rate of solubility, or how quickly something will dissolve. There's four major factors that we look at. First of all, we look at surface area. By breaking a solid or crushing something, you are increasing the surface area, thus increasing the amount of surface exposed to the solvent. Temperature is a major factor for solutions because when you increase the temperature, it speeds up the movement of the solvent particles, which increases the rate at which it dissolves. Agitation, or stirring, or shaking something, also increases the rate of solution because more solvent comes into contact with the solute when you're stirring something. When it comes to gas solutes, pressure is a major factor because pressure pushes the molecules of solute closer together with the solvent, making it easier for them to mix together. So in chart form, the two typical solutes we use are gas solutes and solid solutes. It's very important to remember the factors that increase the rate of solubility for solids. Surface area or crushing something will increase solubility in solids. Increasing temperature will increase rate of solubility. Stirring or agitation will increase the rate of solubility. When it comes to gases, the best way to increase the rate of solubility of the gas is to increase pressure. So remember, for solids, crushing, heating up, and stirring. That's how you increase the rate of solubility for solids. Now, when we are talking about the solubility of something, We're talking about the max amount of solute that can be dissolved at a given temperature. Remember, I just said that temperature affects the rate of solubility and it affects how much you can dissolve. Solubility, when I say the solubility of something, I'm talking about how much solute can be dissolved. Things that are concentrated have a large amount of solute. Things that are dilute have a small amount of solute. So if I can dissolve something, a lot of a salt into a solution and make it concentrated, it has a very high solubility. If it doesn't dissolve very well and I can only dissolve a little bit, it's very dilute and has a low solubility. There's 3 other words that we use to describe how concentrated or dilute something is. First of all, we talk about unsaturated. Unsaturated means that you can dissolve more solute at that given temperature. Let's say you're making Kool-Aid and you only use half the packet. You would have a very unsaturated Kool-Aid solution. Well, let's say you use 2 packets and you dissolve so much at the current temperature that no more will dissolve. Then you've made it saturated, meaning that it contains, or the solvent is holding all of the solute it can possibly hold at that given temperature. Typically when you make Kool-Aid, that's when you use 2 packets. Now, if you were to take your supersaturated solution, heat it up, and dissolve more, then cool it back down, you will have a supersaturated solution. That means it contains more solute than the saturated, but it's at the same temperature as the saturated. So let's say I take my 2-packet solution, I heat it up, and I can put in 4 more packets in this hot Kool-Aid. And then I cool it back down. Well, that solution now has more Kool-Aid in it than it normally would at that temperature, making it supersaturated. Last thing you need to know is the effect solutes have on freezing and boiling points. A solute will raise a boiling point and lower a freezing point. That's why when you have, like, if you have your arm and you put some salt on your arm and then an ice cube, it burns. It's way colder than normal because that water and salt make a solution. That salt's a solute and it lowered the freezing point. If you wanted to cool things down very quickly, if you had a cooler and you had some drinks in this cooler and you took some salt and put it in there with some ice, it would cool very quickly because solutes lower freezing points. They make freezing points colder than normal. Okay, we went over a lot of things in this video. So from this, you need to know what the parts of the solution are, how to affect the rate of solubility, and what the difference is between unsaturated, saturated, and supersaturated, and the effect that a solute has on boiling and freezing. I will see you in class, folks.